Hello everybody and welcome to a chat from the engineering desk. It is a Sunday afternoon and I'm in the mood for a talk about the software which I'm using on the automatic plant watering or irrigation kit, whichever you please, device that I've cobbled together here to water a plant. Now I've had it running for about a week and it's been working very nicely. Some of it has worked as predicted. There have been one or two surprises. So let's talk about what's going on here in the software, because that's the aim of this video, is to talk about the software. Sensor wise, it's very straightforward. We've got a DHT11 connected to it for temperature and humidity data. Pump pin 10 is the output to the relay, which I'm using to control the pump. The kit requires you to run it off the board, which has got H-bridge on it. There are two problems with that. I could not work out how to send the right signals to the H-bridge to get it to do the H-bridge thing. The other thing is that the pump draws quite a bit of current off the 5 volts and it causes the micro to reset. So I used a digital output and a relay and a separate 5 volts for the pump instead. That solved that problem. So we got some variables here that we declare. Soil in pin, that's an analog. And then a couple of variables to store calculations in and so on. Let's have a look at the setup. So I tell it that the pump pin 10 is an output to drive the relay. Our soil pin in is input, analog input. I'll make sure that the pump is turned off. I'll flash up the serial port because we're reporting data. Couple of things, and then see what's happening. And then, because I'm recording how many times it has pumped and given water to the plant, I read that back from the EEPROM, and that is I've got it as address 0. I'm using the first one, the location. Because it's an 8-bit value, it gets to 255, you obviously got to stop or reset the value. So that's what I'm doing here. If it's watered more than 254 times, set the counter back to 0. And then reset that value in the EEPROM. So that's what's going on there. Now in the loop, sensor value is analog read, soil in pin. So that's the value from the fork in the soil that I'm reading. Now then convert that value to an R2000 value. It becomes soil value. We read the DHT11 because I want to know what the temperature is, but I'm also reporting the humidity. One could record that data. So ambient temp is the value I'm after. I then say temp comp is ambient temp plus temp base, which is 0. So the set point is temp comp plus reference, which I've set to 720. The reason I've done this is because the soil conductivity, which is what we are measuring with the fork in the soil, is dependent on the temperature. So the reading goes up as the soil is warmer and the reading goes down when the soil is colder. So on a cold day, like we had this morning, this thing will start pumping water even though the plant doesn't need it, because it got very cold here because it snowed this weekend. So what you need to do is temperature compensation to prevent that from happening. So that's what we're doing there. This is the serial data that we output. How many times it's watered, the set point, the measured soil value after the correction, temperature and humidity. So these are the values coming in over there on the serial monitor. Now there's a delay here of a second and a delay here of a second. One of the things about the DHT11 is that it's quite slow. So you got to give it a lot of time when you interrogate it. Otherwise you can get bad readings. So if you're using one of them, don't be in a rush to get your readings out of it. Now let's have a look at the control. There's not much going on there, it's simple once again. Your soil value is less than set point. Then turn the pump on for 2 seconds, turn it off again, and wait for a minute, and increment your water count, how many times you've watered, and then store that in the EEPROM. Now this is basically a little bit of a PI control. So your proportional response is 2 seconds of pumping, and thereafter the integration happens where you wait a minute and then you go back and recheck to see what has happened, and if need be, more of a proportional response followed by an integration. So you're waiting for the water to soak through the soil and get to the sensor, and then you check if the soil moisture is now at the point you want it for the plant. That's what's going on there. Now I find that to work very well. The biggest thing I had to do this morning was add in the temperature compensation over here, because it's about 2% per degree C that the soil conductivity measurement varies as a result of temperature change. So it's quite a lot. So if you don't compensate for that, you've got a bit of a problem on your hands, or a mess. In this case, luckily I've got a dish, a flood containment dish underneath my plant. This morning I noticed it was just pumping and pumping, and the reservoir is going down, and I'm thinking the dish must be collecting water, and yes it was. So some intervention took place. These things happen. But anyhow, now it's sorted out. So it's been running for a week. We're going to give it another week and see how the control works, and refine it some more. The hardware on this thing is very straightforward. It's nothing complicated, nothing expensive, fancy, any of that type of stuff. It's off-the-shelf stuff, a few components, right? But the software on it is the interesting part. That's where the development and refinement takes place of this control system, which is why I'm talking about the software here today. And we're going to have a follow-up video about it and see what it looks like in a week's time, because it's a very interesting project. It falls back onto gardening and agriculture and that sort of stuff. We're automating the irrigation. Is a very relevant topic, as we would say. So there we have it. I'm going to conclude this talk at this stage. It is time for the beverage of choice on a Sunday afternoon. So I'm going to leave you to comment down below and like and subscribe and hit the bell notification icon so that you can be back next week for more. And have an awesome Sunday further. I'll see you for more. Cheers, everybody.